Alright, now today what we are going to start talking about is the differences. Well, one of the nice things that we can do about these derivatives is anytime that we are required to graph, we can use derivatives in order to graph things, understand what's happening in a graph that we don't even have in front of us. So just by knowing the basic trends of what's going on here, we can figure out how things are going. Right? So, let's say that we wanted to graph something or know what's going on in the situation of the graph x equals t cubed I hat. Okay, in this case here, by simply taking derivatives, we can determine what's happening uh, with the trends of the slope at any given point. Now, let's just first start by taking a look at what this graph would look like. Alright, now from remembering what was going on in calculus, which was a long time ago for me, but a graph of t cubed is going to look something like this. Okay? Now by adding different numbers in here, you're not going to have it looking so simple. If I had t cubed plus something t squared plus something t, then it's not going to be quite as pretty. But this would give you the general trend here. Okay, now as you're noticing, what's going on here is anytime starting at negative infinity and going forward, that slope should be relatively positive. Okay, now it's important that we identify points that are what are called relative extrema. Now, relative extrema are basically maximums and minimums. Just a fancy way of saying it. Now, in other words, we're going to be able to determine what the maximum speed is, what the maximum acceleration is, based entirely off of this graphing stuff. Okay, now I'll talk about how to find that here momentarily. But the first thing I'm going to do is I'm going to take the derivative of this with respect to t. So the derivative of x with respect to t, in this case here, 3t to the second, direction stays the same. Okay, now with this now tells me what the velocity is at any given point. So this will tell us the general trends of what direction the particle is moving at any given point. So by having this information, we can figure out positive slopes. Anytime you have a positive slope, the distance is getting greater. Anytime you have a negative slope, the distance is getting smaller. So with this, let's first figure out what's going on here. All right, the key thing to look for is find when slope is 0. Because remember, just think about it in general here. Anytime that you've got something that's changing, let's say instead of having this, if I were to have a parabolic graph, where the slope is negative and then turns positive, before that slope can change in concavity from going to negative to positive, that means that at one point that slope has to be a 0. Okay, so let's find any point in this graph where the slope is 0. Well, the nice thing is when we find the derivative, that tells us slope. Set this equal to 0, and that's going to tell us what's going on here. Alright, so 3t squared equals 0, divide both sides by 3, t squared equals 0, take the square root of both sides, that means that t equals 0. So, at a time of 0 seconds, you have no speed. So it comes to a complete stop at time equals 0. It's just a split second. Anytime before or after that, it will be gaining or losing speed. Okay? Now, once we have that value, once we know what's going on here, we can start looking what's before and what's after it. So by identifying that point, we can then pretty much identify what the rest of the graph is going to look like. Right? So, what I'm going to do now is find test points. Right? I'm going to pick one test point that is before this, one test point that is after this. Because like I said before, you cannot go from a positive slope to a negative slope without finding a 0 slope. So, with this, I'll make it as easy as I can. I'm going to pick a time that is less than 0, So we'll go time -1. Now, for the most part, we're not going to deal with times that are negative. The only things that can go back in time are Michael J. Fox and SpongeBob, but in this case, we're going to work with it. So we plug -1 in there. 3t squared equals question mark. Put in my -1 as my test point. -1 squared, -1 times -1 is 1. 3 times 1 equals 3. It doesn't matter what this number is. What matters is that number's sign. Right? That sign is positive. That means that the slope is positive. So, for all points where time is less than 0, that means that the slope is positive. Okay? Now, I need to test at a different point. Let's test one after 0 just to see what happens there. So, let's pick another test point. Instead of -1, I like making my life as easy as possible, so let's pick +1. 3t squared equals something. 3 times 1 squared equals, I'm not even going to waste my time on this. 1 squared is 1, 3 times 1 is 3. So once again, I'm not worried about the number, I'm worried about the sign. So anytime when t is positive, anytime greater than 0, then that means that the slope is positive. Right, now I'm going to talk about what this means in the next video lesson. I'm running short on time on this one. But this is the start of it. Don't worry about it too much at this point. We will pick it up on the next one.